guys, Mrs. Horn here. Last we met, we were talking about physical and chemical weathering, and I kind of cut short the rest of the chemical weathering because I messed up my video by trying to give you the YouTube of Howe Caverns. So I need to finish a little bit of the chemical weathering, and then I'm going to talk about things that make weathering go faster or slower, and then we're done. There's not that many notes for this unit, which is one of the reasons why it's my favorite, and I always have a lot of hands-on fun stuff for you guys to get dirty with, so I'll have to be a little more creative with that this year. So let's pick up where we left off, and we were talking about chemical weathering. And the only type of chemical weathering we had talked about so far was carbonation. And that's why I had you look at the Howe Caverns video, just because I wanted you to see what it looked like on the inside of that big cave. That was all limestone rock that had been weathered away by a process called carbonation. And that's when water mixes with carbon dioxide. It makes a really weak acid called carbonic acid. And that carbonic acid would slowly, over millions of years, eat away at the limestone, like these little pictures here, and slowly, but most definitely, make a beautiful cavern underground. Which, if you know anything about Howe Caverns, it was discovered in kind of a cool... well, I don't know if it's cool, but it was an interesting thing. Mr. Howe was actually a farmer, and he had a bunch of cows. And one day he noticed all of his cows were hanging out in the middle of the field. He walked out there to check out what was going on, and they're all standing there getting a cool breeze of air. It was like a 90-degree day. And when he looked into where the cool breeze was coming from, he realized it was this huge cave underground, and that's where the cool 52-degree air was coming from. So I want to get rid of that, but I want to talk more about chemical weathering, and I want to give you some more ways in which that can happen. The second one is called hydration. Don't forget, if I talk too fast, I need you to pause the video so that you can catch up. Hydration. When you think of the word hydration, you think of water. So this is when water dissolves minerals in a rock. And if water is dissolving those minerals, that means it's changing the chemical composition of rocks. Hence, that's why this is another example of chemical weathering. Our third method here is called oxidation. Oxidation has the word oxygen in it, or at least I'd like you to think of oxygen. We know we have oxygen in the atmosphere, and when that combines with some certain minerals in a rock, it changes the rock. For example, when oxygen mixes with iron, it forms something called iron oxide, which is rust, which I have some rust on the outside of my truck. And that's because oxygen has mixed with the iron. We got two more to go here. We have another one called plant acids. There are some plants that produce very weak acids that can dissolve some minerals inside a rock. So if we have plants growing on or near rocks, if they were to release these kind of weak acids, it could slowly weaken the rock over time. Speaking of acids, there are also man-made acids. We have acid rain, we have sulfuric acid, we have nitric acid. These are all things that humans have created, which over time will chemically weather rocks like shale, limestone. There are some statues that we have around New York City or Washington, D.C. that are made of weak rocks that have been dissolved and chemically weathered by our acid rain. Okay, so we've talked about physical weathering, we've talked about chemical weathering, but what things might make it go faster? What things might affect the rate of weathering, whether it be physical or chemical? What might slow it down? What might speed it up? Well, the first thing is climate. Okay, climate has a very big role in affecting how fast weathering happens. For example, if we are in a warm climate, the dominant type of weathering is going to be chemical weathering. So warm climates are mostly chemical weathering, whereas cold climates are mostly physical weathering because it involves ice. Precipitation is something else that affects the rate of weathering. As we have a lot of precipitation, so as there's more rain or snow, the rate of weathering is going to increase. As we have a lot of precipitation, as the rate of precipitation increases, the amount of chemical weathering will also increase. Chemical weathering happens very quickly in warm environments that are also very humid or moist. In different types of climates, like dry climates or humid climates, the landscape of the area actually tends to look very different. So in a dry or arid climate, if you look at this picture here, the landscape of the area has sharp angles to it, has sharp dips and sharp angles. Whereas in a more humid climate, so this is more rain, more moisture in the air, the landscape of the area is much more rounded. I want you to write at the bottom of the page there that the greater moisture equals greater weathering. So the more humidity in the air, the more precipitation there is in an area, the more weathering there will be. What the rock is actually made up of does make a difference in how easily it can be weathered away. So if it's made up of really soft minerals, then it's going to weather away very easily. If it's very hard minerals, it's going to be more resistant to weathering. If I look at this picture here and it's asking what rock type is most resistant, I would want to look for the one that has the most amount left. And if I'm comparing A, B, C, and D, A has the biggest chunk left, so therefore in this picture, limestone is most resistant. Which one would be least resistant? Meaning which one is going to weather away the fastest? That would be the one in which we had the least amount left. So that should be letter B, which is the shale. The particle size of a rock does have an impact on how quickly it will weather away. If there's more surface area, so if the particles are really, really small, giving it more surface area, the rock is going to weather away faster. Okay, so smaller particles weather faster. So as the rock breaks into smaller pieces, the surface area is going to increase, and therefore the rate of weathering is going to increase. Okay, so when rocks are weathered and they're broken down into really, really small pieces, they're broken down into sediments. We've talked about sediments before because sediments are what make up sedimentary rocks. You might have to press pause here so that you can get that all copied down, but this is right in your reference tables. Okay, there are lots of different types of sediments. We've got boulders, we've got cobbles, we've got pebbles, we've got sand, we've got silt, we've got clay, and then we have something we have not talked about yet, and it's called a colloid. And a colloid is a very, very small particle. It's actually so small you can't even see it with a regular microscope, like a microscope I would have in class. And it's so small, I'll show you a picture of it here, that it wouldn't settle out in water. The picture on the the picture on the left is just water. The picture on the right has colloidal particles mixed into it, and they're so small that they just stay dissolved in the water. So the water's not ever going to look very clear. It's always going to look a little bit cloudy because it has really, really, really small particles floating around in it. Okay, other things that are produced through weathering, one of which is going to be dissolved minerals. So when rocks are broken down, we know that rocks are made up of minerals, so it's possible that some of the pieces are made up of just minerals. Those minerals can get dissolved into water, maybe water that's on the surface, like in a river or in a pond, in a lake, or it could be dissolved in water that's underground. Where I live, I have a well for my house, so all of the water that I get comes from the ground, and there are minerals dissolved in my water, which makes my water very hard. So I have to have a softening system in my water so that water can come through all of my pipes without ruining them. And another thing that is made when rocks weather into smaller pieces is dirt or soil. Soil is a combination of really small pieces of rock and organic stuff, like things that were decaying, leaves, animals, fallen trees that have been broken down. That with rock is what makes soil. You probably have heard of hummus, but the hummus that you buy in Wegmans is not the same kind of hummus that I'm talking about here. Hummus is actually a natural type of soil, but it's made up of just decayed plant and animal material. It's very rich soil and very good to help plant growth. Depending on where you live, the type of soil will vary in how deep it is, what it's made up of, how old it is, its color, its texture. The soil that we have here is very clayey, so the particles are very, very small. But if you were to travel to, let's say, Boston, Massachusetts, they have very different soil. They have very, very dark soil, and it's very, very rich in nutrients. Soil can be organized into different layers, and you might need to pause the video here to get all this copied down, but every layer has a name and a description of what kind of stuff is in the soil. So we have topsoil, we have subsoil, we have different horizons of soil, and then at the very bottom, when there is no more soil, that means you've hit bedrock. There are two types of soil. Soil is either going to be residual or it's going to be transported. Residual soil is soil that was made from that bedrock, and then transported soil is soil that was made somewhere else and moved to a different spot. Chart that I have on the last page of notes here is going to compare our physical weathering and our chemical weathering. So physical weathering is going to happen mostly in very cold and very moist climates. By breaking apart rock, it's going to create more surface area, so it's going to change the size and the shape of a rock. As it breaks rock apart, the minerals stay the same. The rock itself is not changing. Chemical weathering, the climate that would most likely work well in is going to be something that's really warm but also moist, so very humid, lots of rain. Surfaces are going to be exposed to not only the atmosphere but also the hydrosphere, so bodies of water. And then chemical weathering is going to weaken a rock or change the actual mineral composition of the rock. Okay, so based on the notes that we took, there are some practice questions that I would like you to work on. Questions 1, 2, 3, 4, and 5. And if you could pause the video right now, because I'm about to show you the answers. Pause the video, then check the answers, then you are done for the day. And here are the answers. Number 3, 4, 3, 2, 4. All right, hopefully you got that, and I hope this helps. See you guys on Monday.